All right, so we look at the last part of it. So we are looking at the data types. We looked at the vectors. So now let's look at lists, arrays, and then matrix. The other parts, the other data types, is not too necessary. It's necessary though, but as you go along, there are some basic things you need to know before we get to that. So I want to pull my, yeah. So this is my R Studio. By now, we all have R Studios in our phones, in our laptops. So, and this was where we ended up yesterday. So let's say if we have the data types, we have vectors, we have matrix, we have arrays, we have lists, and we have data frames. So the vectors, we already know how to construct a vector. So let's look at, but to construct a vector, there are several ways of doing that. We could have the logical, we have integers, we could have, numeric, complex, and characters. We've looked at numeric and characters. Let's look at logical and then integers. And of course, from there, we can go to the other data types. So, so let's say, and I'm saying that when we begin anything with a hashtag, we are commenting. So here we're looking at the data types, and uh, we are actually looking at vectors, and the vectors we're looking at what is it? Let's say logicals or logical vectors. So in logical, we are talking about either something is true or it is false. And now let me give two examples. So if I have, let's say, a vector here, let me call that one vector one. So I have that, let's say, vector one here, that's my variable. And I'm going to create a vector like this. So I'm actually going to use the concatenate function and the vector is created. When you click if you press shift and 9, it will just open that small bracket for you, open and close. So I have a, let's say, I want to do 2 to, let's say, 6. I want us to establish how logical, what are the vectors are being created. And it returns a boolean like true or false and that order. So this is logical. Like you've already seen it here, I'll be iterating. So logical is either true or false. But I want to illustrate where we have this true or false when you have your vectors. So that's why I'm just doing this. So when we come here, I'm going to create a vector. I'm using the concatenate function. I'm going to say 2 to 10. And I just put 2 there. If you put 2 colon and then you write 10, you are going to create. So if you just run it, it will be there. So let me say I have vector 2. So BT2, and then also have the same, and I'm going to do, let's say, this array is to 11, right? So when I run it, I can actually run that. So I have the two vectors. So let me come here. I can actually print any of them. So if you say VT1, you just run it, it's going to print in the console as you can see. So it has been printed. I could actually print the next one, VT2. That one has also been printed. Now, how do we apply the logicals here? Now, let's say that already we know how to apply mathematical operations on vectors. We did that yesterday. So now, let's say that we want to know whether vector 1 is the same as vector 2. And in R, when you do double equal sign, equal, you're actually asking whether something and something are the same. Are they the same? When you use only one equal, it's an assignment operator. It means you are assigning something to the other. But when you say equal, it means you're actually looking at whether what is on the left is the same as what is on the right. So let's find out whether uh, this particular vector 1 and vector 2 that we have created, are they the same? So when you run that, it will return the logic, the logical, the boolean, whether true or false. As you can see, it has returned true. It means the vectors are the same. All right. So let's do another operation on it. Say vector 1 here, let's say is greater than, so we can say is greater than vector 2. So when we run that, it's going to say false, not greater than. All right. So let's find out whether vector 1 is, let's say, is greater than or equal to vector 2, and then we run that. It's also going to, it's not equal or it is not the same as vector 2. Now, let me explain what has happened here. If we come to the console, when we printed vector 1 and vector 2, you can see that we have some numbers. What is it? 1, 2, 3, up to 10. The other one we have 3, 4, in that order, up to the last one. So the first one, we ask a question. It was kind of like we ask a question, and then what arrow will do is to compare them head-on comparison. We said vector 1 and vector 1, they are the same. That's why it returned that they are the same. Because if we compare vector 1 and the same vector 1, it will be the same. Now, let me say vector 1 and vector 2. If you run it again, you will see false, false, false. Why? Vector 1 has 2. I think I should print all of them and we all can see it so that the explanation will be easier. This is vector 1. This is vector 2. So what arrow does is that if you want to find out whether they are the same, arrow will simply map their component. Component 1, component 2. Are they the same? 2 and 3 are not the same. So it will return a Boolean, say false. 3 and 4 are not the same. It will return. So that's how we apply logical operators in, what is it, arrow over there. So that's for vectors and logicals. You can actually apply all sorts of mathematical operations on the two vectors you have created. You can actually divide vector 1 by vector 2. But what we need to know is that when you create two vectors and you want to apply mathematical operations, you should make sure that the content of vector 1, I mean the numeric, the number of items in vector 1 should be the same as the number of items in vector 2. That's all. For instance, if, let's say, I should change vector, okay, no, let me not change, let me create another vector here, and then I'll call that vector 3, and then assign that to, and then just use it to create, let's say I have 3 again, and that is, and 3 is to 14. You know that 3 is to 14, they are not the same. So if I come here and I want to compare vector 3 to vector 1, already you can't even get the comparison. It won't work because vector 1 has the number of items in vector 1 is not the same as number of items in vector 2, right? So if you come here and you say vector 1 like this, and then you apply any of the mathematical operations, let's say equal to, let's say, vector 3. Let's run it and see what is going to happen. You see that they will say that longer object length is not a multiple of shorter object length. That's what it means. It means their content are not the same. So we should always make sure that we have the same entry in each vector before we can apply mathematical operation. But when you do this, if the content is the same, you can apply any mathematical operation on them and then they will work because you've packed everything into them. That's about the logicals there. Now let's look at another aspect of another aspect that so the integers is where you have characters and then the numerals mixed together. That's where you have integers. This is an aspect I will not touch for now. The numerics, we've already done much of the numeric. That's what I've just done. Complex, they are like what is it, mathematical formulas, and then the characters, we already know the character that we have. But let me do this quickly before we run out of the character. Let's see whether, if we have characters, we can actually compare two vectors that contain different characters and what is going to happen. So let's say I have, let me go back to the R Studio. So I have, let's say I have vector 4. Let's say I have vector 4. And then I'm just going to assign it to some characters. So let's say I have A, I come out, I have B, I come out, I have A, comma, I come out, I have B, comma, then you come out, then you insert, come out, and then you put B, come out, comma, and then you put C, then I come out and put comma and put D there. So D is there. When I come out, I'm just going to close it up. Then let's see whether it ran. Yes, that has run. So let me put another vector. Let's say that's vector 5. And then I'm going to assign that to another. Yeah, I know some people might ask me why I'm just focused on vector. Because whether you are creating matrix, you are creating list, you are creating data frame, you have to use vectors to be able to do that. So if you understand the vectors, it becomes easier. Even when you are looking at a data frame, when you have data frame, it's just vectors that has been in in the form of a column. So if you take a whole column and you print that column out, it will come as a vector. So it's important to understand vectors very well, how to apply mathematical operations on vectors. And if we do that, when we go to data frame, it's the same thing. It's just a matter of, locating that particular column, which is the same as a vector in a longitudinal presentation or format. And then you can apply the same mathematical operation and it will work just the same. So let's try the characters and see whether that one too, it works. So I have A here. I'm going to come out, then create another one. Let's say C. Come out, create another character E, and then come out, then create another character called H. So let me run that. So these are also vectors of characters that we have created. Let's find out whether we can compare the two. And see if. So let's say if I have vector 4, which is made of character A, B, C, D, and then I want to say that it's the same as vector 5, which is made of A, C, E, and H. Run it and see what is it going to return. So let's go and run it. You see that it will return true, false, false, false. It means A and A are the same, but B is not the same as C. C is not the same as E, and H and D are not the same. So it will return the same Boolean and as it is. But that's about all. You can't apply any other mathematical operation on this because you can't say greater than or something. You can't apply. You can't say plus this. I'm not too sure that it's going to work. If we I can actually try it and then you see that it won't work. For instance, if I'm going to copy this, it will make it quite easier. There's no time. So if I do this and I put plus there, you see that already. Let's run it and see what is going to happen. It will tell the error because they are not numeric arguments. So the argument we have put in each of them, they are not numeric. So you can apply mathematical operations. But for this equal, you are just saying that the entries are they the same. So I will just check and see whether the arguments are the same. It will just return. But apart from the finding out that you can't apply any other mathematical operation. Now that's about it for vectors. Now let's go and look at the other data type quickly, which is matrix. Now, if we have matrix, there is a syntax for it. You always use the function called matrix itself. Whatever is followed by it should be the data, and then you have to indicate the number of rows, indicate the number of columns, and you have to say by row, and then you add the dimensions name there. So let's go and look at that quickly, and then we illustrate the example, and then we can come and look at it. So let me pull up some more, come to here and say, okay, our hashtag, we are looking at data types, and then we are specifying only matrix or matrices. I don't know the plural form, how it is. If I come here, the function is matrix. When you put matrix already, it will simply bring this. And one interesting thing about R is that any function that you put, when you put your cursor there, it brings out the argument or the syntax on top of it. And then it will tell you how you are supposed to put it. Now, let me type matrix again and you see something. Yeah, I'm going to cancel this and come and type matrix. So if I say matrix and I come, look on my right hand side on the screen, you will see that we have data followed by the number of rows. You have to indicate number of rows. 1, number of columns. 1 by row is equal to false. Let me put this before I explain what by row means equals to false. Now, if I click this, so first of all, I'm going to indicate my data. So let's say I have a data of, let's say, 1 is to 12. That's my data. Then I have to, then I put comma and I shift small. So n row, the n row means number of rows. The number of rows, as we indicate, number of rows should be, okay, 3. Then comma, n col, that's number of columns. It should be 4. And then I simply go and say by row. By row, if I say false or true, what does it mean? So I'm going to write one of them, run it, and I'll explain what that means. So I'm going to do this. But false is a Boolean, so false is one of the inbuilt functions in R, so it's already there. So I just put this and run it. What do you see? You see it runs perfectly. Let's come here and look at something. We have number of rows, 3. Number of columns, 4. That's how we are able to do our matrix. So we just created a data set, and the data set is from 1 to 12. How many rows and how many columns? Please, in matrix data creation, the data set, you should know how do we call it? The data points. How many are they? 1 to 12 means we are creating a data of 1, 2, 3, counting up to 12. So we have the data points at 12. If you are putting number of rows and columns, and the multiple of the two will not give you 12, it won't run. All right? It will not run. So anytime you are putting, you should know your data here. The data points, how many are they? They are 12. So if you put here number of rows 2, and you put here number of columns 4, 2 by 4 will give you 8. That will not be equal to the data points here. That's the point I want to emphasize. Now, the by row here means, do you want R to represent your data by the rows that you have indicated and column that you have indicated, or R can suggest its own number of rows and its own column number of columns? So if I indicate here true, I am saying that R, go by what I have given you. If you indicate the false, R can decide to suggest any number of rows and columns for you. All right? So that's what this means. So I could package the whole of this into and say, I'll call that one my matrix 1. So I'll just say mat1. And that's my variable. And I just put this there and then like this. So now if I run this, it's going to package everything into my matrix 1. And so that it will be there. So you can do this as many times as you want. That's how we create matrix. Simply you have your data and whatsoever. This 1 is to 12. There are several ways we can do that. You can actually use sequence, you can use repeat and whatsoever. Now let me do it in the form of characters and we see. So this will be mat2. Then I'm going to assign that to, by this time around, it's going to be characters. But characters, how do we do? I'm going to use a repeat function. This is also another inbuilt function in R. So, and I'm going to repeat a character called, whose name should I use? Kasim, right? Okay, Kasim. So, by characters, as we say in R, you can't just write character that, you have to be in double quotes. So I have Kasim here. But how many times do I want to repeat Kasim? I want to repeat Kasim, let's say 12 times. So I'll put here 12. Then I come out of that because I have finished with my data. Now I'll now say how many rows do I want it to be? I want it to appear. So you say your n row will be equal to 3 as we have it on top there. And then I put my comma. My n column will be equal to 4. Then my comma there. Then by row, this one, you don't have an option. That is the order, that's the syntax. And I'm going to say like this. When you start typing, anything that is an inbuilt function in R, when you start typing, you see that R will suggest it for you. You just click on it if you want it. If it doesn't fall there, you leave it out. So let's run this and see. You see, it runs properly. Now come and print your matrix 2. Mat 2, which like the way we have done it, Mat 2 will come, obviously. When you run it, you see that it has repeated the name Kasim how many times? 12 times, but in the dimension that you have indicated. So you have Kasim on 3 rows and then 4 columns. So that's how we do that. Now, this function I've used repeat, please. We haven't come to that. There will be a specific day that we are going to deal with inbuilt functions in R. We will look at many of them. How to create random numbers, index numbers, how to run up, run down, sequencing, and whatsoever. We'll look at as many as 25 of them that I have checked up already. So this is how we create matrix. You can try it using different data sets. And I said that in R, when you have something 1 is to this, you are saying create them from beginning from 1 up to 12. Somebody asked me this question yesterday. In Python, it's not the same. So, and let me indicate that when we get to Python, I'm not going to be the one that will be teaching you. Somebody who knows Python quite better than me will come and do that. And the person will mention that in Python, this 1 is to 12. It's not like that. Languages, all the computer, they have their own languages like, and we should understand them as such. So this is how we create matrix. Now, maybe somebody will ask me, why do we need this matrix? Now, if you are going to plot your data, and you're going to plot something like a stack bar plot, you need to convert it from data frame into matrix. Matrix data are always very important. For instance, when you are collecting a repetitive data, let's say that you have, 20 students in your class, and you want to measure their behavior over time. So you see that it's the same number of students, but the attributes, what you are measuring, will be repetitive. Maybe they are dressing. So you can put dressing here. The time they come to school, the kind of food they eat, you put it there. Maybe their hobbies, you put it there. 4 important variables you are measuring by the same number of people. So you see that it will be repeating. You can have number of times they come to school, can have many different times. So if you are going to build that kind of data, you need matrix. You need matrix to be able to do that. And then you also need to plot it in a stack bar plot so that you can compare each person. Okay, this is me, Bright. Okay, when it comes to the times of coming to school, you can compare it across all of us. The time that the hobbies, you can compare it across all of us. And you use stack bar plot to be able to do this. And that's why we are learning about these things. So that's about it for matrix, how to create matrix. I don't think I have anything more to add to this. What is the next data point that we needed to create? I think the last thing we need to look at is list. List is, I think, I don't know. I have to ask those who know R way better than me to help me. I don't know where we actually apply lists. But nevertheless, we'll look at it, how list is being done, and then all of us can have a feel of it. But before that, let's look at array, how to create array. You see, there's a difference between array, data frame, and then matrix. So after we have created the array, then we will look at what are the differences. There are individual differences. Where are they being applied? Data frame, we know where it's being used. Matrix, I've just told you, if you want to compare one variable that has different attributes, those in statistics will say small n, big P. That's where those differences come in. So what about array? Do we also have something like array? Yes. If you have, let's say, or should I do this in a separate video? Array and list. I think I'll leave this video for now here, and then we will look at arrays. Then we will look at list 2 on a separate video, and then you will have that completed. Thanks, and then try, and then we'll meet at 7. Thank you.